Alright, so here's another example. F of x equals 4x times e to the 3x minus 1. Now this is a product rule because 4x is one piece, e to the 3x minus 1 is another, and they're multiplied. So you gotta look out for that. So the derivative of the first times the second, which is 4 times the second function, plus the first times the derivative of the second. Okay? So the first is 4x, the derivative of the second, so the derivative of the exponent, which is 3, times the function again. And we can simplify that, so bring the 3 out here, 12x. Okay? And then pretty much all the time in this, we have the e to the 3x minus 1 we can factor out. So we're going to factor that out. And this is useful when you're trying to find, say, maxes and mins, or stationary points. Because when you go to solve this equal to 0, now you have this part that you can solve, so x equals negative 1/3. An exponential function never equals 0. So this part never equals 0. You don't have to worry about it. Okay, so for example, if you had, here's an exponential function, it never equals 0. Right? So you don't have to worry about that. Okay, what about this example here? We've got a quotient rule with a trig function in it. Okay, sine. So here we're going to take the derivative of the top, squish it all in here, try to zoom in a little bit. Okay, so the derivative of the top, which is this, times the derivative of the inside, times the bottom, minus the derivative of the bottom. Okay, so we write the whole function, times the derivative of the exponent, times the top. Okay, I know I've written that small there, but that is just the top of that function. Over the bottom squared. You can't forget about that. Over the bottom squared. Okay, and from the product rule, we can usually factor out this piece here out of the top. So I'm going to factor that out. And I get, when I factor that out, this is what I get left over. And now I can cancel that out with one of these, the squared thing on the bottom. Usually reduce that bottom power exponent. Okay, and then this will be the final answer. Okay. Now, what about logs or exponentials with a base other than e? Okay, so as I've mentioned before, for a greater than 1, any number could equal e to the b. Okay, so a could be e to the b. There exists a b value for that. So then log base e of a equals b. So just using our log rules, if this is true, and you want to solve for that b, you take the log base e of both sides. Okay, so it gets you b. Now mathematicians like this logarithm, and they've come up with a name for it. It's called the natural log, so ln of x. And this is on your calculator as well. Okay, so whenever you see ln of x, you're thinking log base e of x. And it is the inverse of e to the x. Okay, so b equals ln of a in this one. Okay, so b equals ln of a. Now let's go for rewriting this statement up here. So if e equals e to the b, or a equals e to the b, okay, then a equals e to the ln of a. Right, so because b equals ln a. Now y equals a to the x. Well, I'm just taking this part here, putting it to the exponent x, which means I'm going to put this to the exponent x. And I'm calling that my function y. So now I have a function a to the x written in terms of base e. And these exponents here, we multiply them together. Okay, so now I can take the derivative without using first principles. The derivative is, take the derivative of the exponent, which is ln a, okay, because ln of a is a constant, times e to the ln a times x. Okay, so rewrite this function. So this is our derivative rule for e to the x. Multiply those in, break that up. And e to the ln a is just a. Okay, so y prime equals ln a times a to the x. Or a to the x ln a, which is what we often want to write. Okay. So when you have a to the x, the derivative is a to the x times the ln of a. Not as nice as e to the x, but if you did this as e to the x, it would be e to the x ln e. But log base e of e is 1. Log base e of anything else is not 1. Okay, so when it's a to the x, it's a to the x ln a. Okay, so that's your summary for that. Now let's try a little example. So for y equals 2 to the 3x, y primed is going to equal, well, 2 to the 3x ln 2 times the derivative of the inside, times the derivative of the exponent, which is 3. And that equals 3 ln 2 times 2 to the 3x. Okay, so that would be an example of that. All right, now for logarithms. I'm going to look at these two. So using some of the same tricks, we can get that for y equals ln of x, natural log of x, the derivative is very conveniently 1 over x. Not as convenient, but still nice, if it's log base a, so not base e, then it's 1 over x ln a. If it was base e, it'd be 1 over x ln e, but ln e is just 1, and you'd end up with that. So this is the more general one. Okay. So some examples here. So for f of x equal to ln of x squared. Let's go straight down here. The derivative is going to be 1 over x squared times the derivative of the inside, which is 2x. And that simplifies, the x's cancel out, to 2 over x. Or you could use a log rule over here and bring that power down in front. Okay, so that is a log rule. You can take that exponent down in front. And then you get 2 ln x. The derivative of that is going to be 2 times 1 over x, which is 2 over x. Gets you the same answer. Either way of doing that. Okay, and let's recall some of these log rules here. So here are the sum rule becomes a product, and the difference becomes a quotient. Okay. Now for something like this, an example, the derivative for this is going to be 1 over this, okay, times the derivative of the inside, which is 2x plus 2, okay, minus 1 over sine 2x times the derivative of the inside, which is going to be cos 2x times 2, because the derivative of the inside of that, and that would simplify to 2x plus 2 over x squared plus 2x minus 2 cos 2x over sine 2x. You could write this as cotan 2x, 2 cotan 2x. Okay, so you could simplify it to that. Sorry, that was out of the camera there. So that's an example. The other thing you could do with this is, or y equals, using this subtraction, you could write that as ln of x squared plus 2x all over sine 2x, using the log rule, and then take the derivative. So y prime equals 1 over that. 1 over that is just the reciprocal. So I would say sine 2x over x squared plus 2x. Now times the derivative of the inside, which is derivative of the top, which is 2x plus 2 times the bottom, sine 2x, minus the top times the derivative of the bottom. Derivative of sine 2x is 2 cos 2x all over the bottom squared. Okay. So that was out of the camera as well. So this would be the answer to that one. And you could cancel out one of the sine 2x's and rewrite that. And you couldn't cancel out this one. Okay, so those are some examples for logs. Okay, so say you had, here's another couple of examples that you can look at for logs right here. Okay. So there is ln of a polynomial, there's a derivative, and here is a product rule. Okay, simplifies.